Welcome, I'm Jonathan Vennard, Associate Professor of Precision Machining at Vincennes University. In this video, we will set up our work offsets and tell the machine where the part is. We're going to pick up the top corner of this part. We'll put it in the vise and tell the machine that that's the origin for our workpiece. First, I will load an edge finder to establish the X and Y values for our work offset. I have set the machine RPM to -1000. The reason I put that in as a negative is so that it spins backwards, which will make the edge finder kick out towards me whenever it finds the edge. Now we'll go to our tool setup page and we'll load the edge finder in an unused tool location. In this case, tool number 10. We will press the auto tool change and load the tool into the spindle when prompted. We'll go to the work offsets page. Now I can turn on the spindle and hand jog over to the workpiece. We'll find the X offset first. We move the spindle slowly toward our workpiece and the edge finder will stop moving as much. We reduce the rate at which we're moving and watch for the edge finder to kick out, which means that we've found the edge. We click on the X offset and we hit store position. The edge finder being used has a 200 thousandths diameter tip, and that's where we found the edge. But we want the center of our spindle on the edge, so we have to compensate for the radius of the tip. So I'm going to add 100 thousandths from this number. I'll type in 0.1 plus enter, and that will store our X offset. Now we'll store our Y offset. We'll hand jog over, flip the tip of the edge finder so it's back off center, and we'll come to the part. We will move into position to pick up our Y offset on the front edge of our workpiece, then slowly start moving into the part. Once the edge finder starts to slow down, we can reduce to smaller increments. When the edge finder kicks out, once again, we will store our position. Since we are edge finding the front of the part, we will need to move 100 thousandths to the positive. So once again, we will press 0.1 plus enter. We have found our X and Y offsets. So now it's time to establish our Z offset for this part. We will do this using a tool that already has a set length in the tool setup page. Now using this known calibrated tool, we're going to come down and show it where the top of the part is. We will use a 1, 2, 3 block once again, similar to when we set our tool lengths. We bring the tool down in Z and use the 3-inch side of our 1, 2, 3 block. I'll bring the spindle down just below the top of our block, and then, while putting the slightest pressure on the block, slowly raise the tool until it slides smoothly across the top of the block and goes across without dragging. Now, in my work offsets, Z offset column, I will store the position, which is telling it where the top of the 3-inch block is. But we need the measurement to where the top of the part is. So I will simply subtract 3 inches from my number by typing 3 minus enter. Now our machine knows that the top of our part is 3 inches below where it sits. We should now see a positive 3-inch value in the part Z position. This confirms our Z offset is set correctly. We can verify our offsets by simply hand jogging to the part zeros in X and Y. The center of the spindle should be aligned with the corner of our part. This is how we set our work offsets on the CNC mill. To learn more, look for our other videos on CNC mill and lathe techniques.